In this problem, we're being asked to solve the system of equations algebraically using addition. And so notice, first of all, that the like terms, the like variables, are lined up. That is, the x's are vertically aligned, the y's are vertically aligned, the equals, and the constants. So that tells us we're ready to start our substitution. And the first thing to notice is the x terms, we have a coefficient of 1 for the x, so we have 1 and 4 for the x. Whereas for the y's, we have a -1 and a +5. And since both of the coefficients in the first equation are 1s, they're both equally good to work with. But because the y's have different signs, one's a negative, one's a positive, that's going to be the best one to work with. So what we're going to do, let's rewrite this so we don't have so much stuff. So we've got x minus y equals 5, and 4x plus 5y equals -7. And what we're going to do in order to get the coefficients of the y terms to be opposites, so that when we add them they eliminate, we need to multiply the first equation, both sides, to keep our balance, by 5. And that's going to transform and give us a new equivalent equation. So we'll take that 5 in front and distribute it, multiply it times the x, giving us 5x. Then we'll take that 5 and distribute it to the minus y, giving us minus 5y. And then we'll also take the y, or the 5 on the right side times the 5 we multiplied by to get 25. Remember, every term has to transform, and in this case, everybody's being multiplied by 5. Now the second equation doesn't change at all. We liked it just the way it was. So 4x plus 5y equals -7. And the net result then, notice, our y terms, if we were to add them, which we're going to do, would eliminate adding to 0. So on the left side, we're left with 5x plus 4x, which is 9x. On the right side, we have 25 minus 7, or 25 and a -7, giving us 18. And in now one quick step, we're down to one equation with one variable. We can isolate the x by dividing by 9, and we quickly have our answer of x equals 2. But remember, that's only part of our answer. We need to now go back to one of the original equations and find the y that goes with this x of 2. So what I'm going to do is take the first equation and just copy it again, x minus y equal 5. And we'll take our answer of x equal -2 and put it in for x. So 2 minus y equals 5. And now we need to solve that equation for y. So we'll start by moving the 2, minus 2 to both sides. That will zero it out on the left, leaving us with -y equals 3. And then to get rid of that negative, we'll divide both sides by -1. And we get our answer of y equals positive divided by negative is negative, 3 divided by 1 is 3. And we can then put our two values, one for x, one for y, together as an ordered pair, 2 for x, -3 for y. And that's the solution to the system of equations. Again, you can check it by putting them in each equation and seeing if they work. You could check them by graphing each of those lines and seeing where they cross. This is the solution algebraically using the method called addition.